Hi guys, I hope you're all okay. Before I start this video on finding angles using the sine rule, I'm just going to kind of point out something in maths that you are probably aware of, but I just want to make it really clear that it's always the case. So it's a fact that it's going to really help us in this video, so I'm just going to start off showing you that. So 10 over 2 is equal to 20 divided by what? So if we wanted to solve that equation, if we just think about it, well, 10 divided by 2 is 5. So what do I have to divide 20 by to make it 5? I'm going to have to divide it by 4. Okay, so here x equals 4. So what I'm going to do now is just flip both those fractions upside down and put an equal sign between them again. So 2 over 10 is equal to x over 20. Now, if I work that out, if I try and do it a little bit more formally, balance both sides, if I do 20, I multiply both sides by 20, that is, and do 20 times 2 over 10 is equal to x, that's going to give me 40 over 10 equals x, or x equals 4. So they're the same. So actually I've just flipped those two fractions upside down and they're the same. And that is actually the case in general. Okay, so just generally, if you have a fraction a over b, which you are told is equal to, let's say, c over d, is absolutely fine, and it's completely true, and it always will be, to say that b over a is equal to d over c. Okay, it's absolutely fine just to flip your fractions round. So if we have a look at our formula sheet, it would be absolutely fine, because this is just a series of fractions which are equal, it would be absolutely fine just to flip those upside down. So I know that getting ahead of myself, a divided by sine a equals b divided by sine b, and c divided by sine c. It is absolutely fine to flip all of those upside down, and it is still true. So I could say, so the sine rule says this, but you could also write it as sine a divided by a is equal to sine b divided by b, which is equal to sine c divided by c. That's absolutely fine. So actually, when I did my GCSEs, and every year you were given a formula sheet, you were given both forms of the sine rule. It's a little bit annoying that you're not, but it's not going to be that hard for you to work it out. So we're just going to bear that in mind as we go through this video to make our life a lot easier. It's not essential that you remember this, but it just does make life a lot more straightforward. So the difference with this video is that we're going to be looking at finding angles using the sine rule. So we are going to be given, again, a pair of opposite angles and sides where we know the values, and then I'm giving you a side and an unknown angle rather than a known angle and an unknown side. Okay, so it's not going to be an issue. So what I'm going to do is, again, just get into the habit of labelling my triangles in pencil. Let's call this side A, and again, it looks quite a lot like this triangle down here. This angle is A, so this side is lowercase a. This angle is B, so this side is lowercase b, and this angle is C. This side is lowercase c. Now you'll see that angle C and side C are completely irrelevant to us here, so I'm just going to focus on A and B. So I'm going to write down the part of the sine rule that I'm concerned with. So A over sine A is equal to B over sine B. Now that is just copied exactly from the formula sheet. I'm just focusing on the bits that I need. Now before I even get into this, you'll see why in a moment. It's going to be a lot easier if I flip these upside down. Okay, so I'm going to say that sine A over A is equal to sine B over B. You don't have to do that step, but it makes it a lot easier if you've got your unknown on the top rather than on the bottom. Okay, it just makes the rearrangement a lot easier. If I get a chance, I will go through and show you, but it doesn't really matter, but it's actually just making you have a lot more work further down the line. So just like in the previous video, I'm going to plug in values that I know. So capital A is 60. So sine 60 divided by lowercase a, that's 12, is equal to sine, or capital B, is alpha, so it's just a Greek letter. We could have used X, Y, or Z, but a lot of the time questions will use Greek letters, divided by side B. B is 8 centimetres. So I can do that rearrangement. Multiply both sides by 8, not touching my calculator yet, you get that 8 multiplied by sine 60 over 12 is equal to sine alpha. So I'm going to type that into my calculator. So 8 multiplied by fraction sine 60 divided by 12. And that gives me 0.577, etc. So sine alpha equals 0.57735026992. Now I've got what the sine of my angle is, but that's not what the question is asking. It's asking me to find what the actual angle is. So I need to do the inverse sine. I need to apply sine, the inverse sine. Okay, so sine to -1. So if I do it on my calculator, I'm just going to press shift, sine, and then answer. It's going to take what that number is and do the inverse sine on it. And it gives me that answer. So 35.264 degrees, which we're going to round to 35.3 degrees, which is 1 decimal place. So it's just made my life a lot easier, the fact that I flipped my sine rule upside down really early on. I'm just going to go back and pretend that we hadn't done that. If we just said that A over sine A is equal to B over sine B. So again, I'm just going to plug my values in. A is 12, sine A is sine 60, divided by, is equal to 8 divided by sine alpha. So if I want to do my rearrangement, I'd have to multiply both sides by sine alpha to give me sine alpha times 12 over sine 60 equals 8. Then I'd have to multiply both sides by sine 60. So already there's quite a lot of multiplying going on here. There's lots of ways I could make a mistake. So sine alpha times 12 equals sine 60 times 8. And then I'm going to divide both sides by 12. So that is a lot of work going on here to get exactly the same answer. Okay, so it doesn't, you will still get there, it's just there's much more chance you will make a mistake. That's why I always like to just remember that trick about flipping it upside down. So moving on to this question. I mean, feel free to pause the video now and have a go at it yourself, or you can just watch on and see me do it. So I'm going to label my sides. Let's just call them, again, starting in the bottom left corner, A, B and C. So that means this is side A, this is side lowercase b, and this is side lowercase c. So I've got my A's, which are opposite, and I've got my C's, which are opposite. So I'm going to write down that A divided by sine A equals C divided by sine C. That is just taken from the formula sheet. Now, because I'm looking for the angle, because I'm looking for sine C, or C itself, I'm going to want to have that on the top. So I'm going to flip that round straight away. I'm going to say sine A over A equals sine C over C. That's really important. Whatever you're trying to find, you try to keep on the top. It just makes your life easier. So there was no flipping in the previous video because I was only looking for sides. I was only looking for the top. So I'm not going to make my life harder. I'm just going to try and keep it on the top. So I'm going to plug in some values. So A, the angle A is 50. So sine 50 divided by 15 is equal to sine C, which here is beta, sine beta over 7. I'm going to multiply both sides by 7, so do my rearrangement. To give me that, sine beta is equal to 7 times sine 50 over 15. I'm going to type that all into a calculator. 7 times sine 50, close brackets, over 15. It gives me 0.35748, etc. I can use my answer trick again, so I'm just going to press inverse sign, so shift sign, answer. That gives me 20.945. Okay, which we can just round to say beta is equal to 20.9 degrees to 1 decimal place. Oh, sure, so I dropped off the page there. So, final one. Again, might run out of room here. It's going to be interesting. I'll do my initial working out up here, and I think I'll finish it off beneath. So I'm going to just label my sides again. I've got a gamma here, just a Greek letter, so nothing to worry about. Let's call that again A, B, C. Doesn't really matter how we label that. And this is lowercase a because it's opposite A, lowercase c because it's opposite C, and lowercase b because it's opposite B. So I can see I've got this pair, which are opposite each other, 100 degrees is opposite 20 centimetres, and I've got this pair, which are again opposite each other, 9 centimetres and gamma degrees. So it concerns B and C, so I'm going to write that down, that sine, sorry, I keep doing this, keep getting ahead of myself, B over sine B is equal to C over sine C. So I'm going to flip that round. And it's going to give me sine B over B equals sine C over C. Actually, what I'm going to do, just demonstrate, I can flip it around at a slightly later stage. I'm going to sub my values in, and then this is probably going to be more relevant for you when you're in an exam and you can't quite remember why you're doing this. I'm going to plug my values in straight away to this version of the sine rule. So that's 20 over sine 100 is equal to 9 over sine gamma. Now my sine gamma is on the bottom, I don't want that, so I'm going to then flip my fractions. It's going to give me sine 100 over 20 equals sine gamma over 9. Okay, so it has the same effect as subbing in here. Flipping first and then subbing in doesn't really matter. So I'm going to do my rearrangement. So that is going to be multiplying both sides by 9. Give me down here 9 times sine 100 over 20 equals sine gamma. I'm going to type that all into my calculator. 9 times sine 100 over 20 gives me that answer there. The sine gamma is 0.44316, etc. So if I do my inverse sine, so shift sine answer, it gives me 26.3 degrees. Okay, so hopefully that has made sense. It is a tricky skill, and normally we wouldn't really bother learning it in set 2. However, it is in the formula sheet, so you might be able to apply it. So hopefully this has been useful. I'm going to upload a video very shortly on the cosine rule. Then I'm also going to look at the alternative way of finding the area of a triangle, and there'll be one final video just to round off trigonometry, looking at all of the rules overall and working out when I should use each one. So hopefully this has been useful, and I will see you shortly.